Okay, when we talk about the await implementation of queue, as most of the concept is already covered when we talk about the linear list implementation, as well as the implementation in stack, and how to make use of the await to do so. So here, okay, what I'd like to let you know is taking very quick note on the some key implementation. Okay, just like here you can see the await queue here. Okay, again, okay, it has a front and rear pointer. It is done by the index. Okay, because we are talking about an array, and it is using array of objects here, and as the constructor, okay, it has the initial capacity. Okay, and if you do not specify, okay, here in this implementation, you just allow it to be 10, and just say it's empty, and to get the front element, and you will see that, okay, it is making use of concept of some circular approach of identification of an element. Okay, if we get the rear element, okay, it's just like the pointer. Okay, so so when talk about put, I would just let it for you to read. Okay, after I would talk about the index. Okay, that's the key thing. Okay, you would like to know more. Why? Okay, when we put the object here, it takes a bit longer than what we would expect. Okay, the key thing is that let's consider the situation that in this way, originally we will place element at the first index 0, and then put the second element to the second, that is index 1, and then the third one index 2, and fourth one in index 3. So the front is pointing at 0, at the rear is pointing at 3. Okay, so it is easy to understand. However, imagine that when there's remove or dequeue, okay, so it becomes empty, and it becomes 1, that is the front. Okay, so it becomes 1. So if you have more item, then the rear or the back is also shifting towards right. So the front pointer is also shifting to the right. And eventually, okay, in this case, imagine that this array has size of 50. Okay, so when you come to the, you know that it is moving to the right. Okay, it comes to the case that the last element is located in the index 49. So what is the next one? Okay, it would be move back. Okay, move back to the first one. Okay, assuming that, okay, it is not that full. Okay, so in this case, what you should do is rounding the index, okay, back to 0. That is 47, 48, 49, then 0, 1, 2, and 3. So if we use one-dimensional array queue, okay, so originally we would like this, but actually it is a circular view. 0, 1, 2, 3, 4, 5, then 0. Okay, so in other words, if we have 3 elements put in this 6 capacity of an array, okay, so it would paste like this. It is one possibility, or it could be another allocation, just like put in 5 0 1. Okay, you can imagine that. Okay, it can also be put in another place. Okay, just like 0 1 2, or 2 3 4, just like this one, or 3 4 5. Okay, if there's one more element, okay, put to position 0. So it is a circular wheel， 即係好似將一條直線扭成一個圓形一樣。咁係臨下變咗一個 circular， 即係因為臨尾佢會指翻上去頭嘅。Okay, in this case, okay, the integer variable, okay, not only for the front and the rear, so it is a one position clockwise from the first element. Okay, and the rear gives the position of the last element. So the front will be one position counterclockwise from the first element. Okay, and the rear will be the last one. Okay, so in this case, the front will be pointing at index 4, and the rear will pointing at 1. Okay, so it will keep track on the front and the rear. And that's why, okay, when you get the front element, and you can see that it's front plus 1. Okay, but you can see that it is modulus with the cubed length, so that if it loop back, okay, to the index of 0 if needed. So if you need to add an element, okay, so rear will move one clockwise, just like this one clockwise. Okay, one element added and put at the Q rear